right, so we're going to spend a lot of time with people who have gotten lost in this chapter. It just seems that a lot of our problems end up looking like this. So we're going to talk about a boat. And a boat has left port, traveled 10 miles, then turned 20 degrees and traveled 8 more miles. And maybe this boat called the Coast Guard, and that's all they know, and they're dead in the water. And so Coast Guard is trying to establish a search radius. Okay, so let's talk about this. So my boat starts here at port, goes 10 miles in some direction, turns 20 degrees and goes 8 more miles. So 10 miles. Now we got to be a little careful here because this is my 20-degree angle. Turn to 8 miles. And what do I need? I need, this distance, right? My sailboat's out here doing its thing. Okay. So, how do I figure this out? Well, the first thing I need is that internal angle. So that internal angle is 180 minus that 20, which gives me 160 degrees here. Now the law of cosines tells me that d squared is equal to 10 squared plus 8 squared minus that correction factor, 2 times 10 times 8 times the cosine of 160 degrees. And now you may be thinking, oh, but wait a minute, cosine of 160 degrees is negative. And you're right, it is. And that's okay. So we're just going to plug this into our calculator. And we're going to take the square root of all of that. So we could do some work in our head, but we don't need to. Make sure we're in degrees. And we're going to take the square root of 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 160 degrees. And my boat is 17.30 miles from port. So my Coast Guard can search within that 17-mile circle to find the boat. That's the basics of the law of cosines. And we can use it to solve triangles. We can use it to solve the sorts of problems that we're facing here. And we can use it to solve, so this problem might look familiar. It's similar to one we had previously, right? And we solved it using right triangle trigonometry. We can also, we can use the law of cosines to make our life a little bit more simple here and solve this using the law of cosines combined with the law of sines. So let's take a look at how we would do this using non-right triangle trigonometry. Well, yeah. All right. So it's always going to be helpful to draw a picture. Take the time to make a sketch when you're solving problems. It will save you angst and heartache in the future if you do that. Okay, so in the interest of time, I've used the picture the textbook gave me. So we've got a woman wanting to measure the height of a hill. She wants to know what she's getting into if she decides to hike up it. Okay, so she stands on the plane and she measures an angle of elevation to the top to be 24 degrees. Then she moves back 200 feet and measures the angle of elevation to be 22 degrees and find the height of the hill. And we've done this before, right? We did it using right triangles And we defined this x, and we went through a lot of work. But we can do this a different way. Now we're eventually going to get to that right triangle trigonometry because that height is the vertical leg of a right triangle, but it would be really nice if we could get this distance here, right? If we could get that invisible distance, because then we know that h over x is the sine of 22 degrees. Or we could know that h is equal to x times the sine of 22 degrees. So let's talk about how we could get that. Well, we can't use the law of cosines because I don't have enough distances. But if I could get this angle right here, then I could get, so let's call this beta. And let's relabel my x to be b. To be consistent with my labeling practices. Because I'm going to label this guy up here alpha. Why did I do that? Well, because I know that the sine of alpha over 200 feet is going to be equal to the sine of beta over b. So if I can find alpha and beta, I can find b. Good news is I can find beta. Beta is the angle of a straight line, which is 180 minus 24 degrees. That's 156. And I'm actually going to go ahead and I'm just going to label that beta. There we go. And so now I know alpha because I know that, oh, I don't need to do all this in red. I know that alpha plus beta plus 22 degrees has to equal 180, which means that alpha is equal to 180 degrees minus 22 degrees minus beta, which is 156 degrees. So I've got 180 minus 22 minus beta. Oh, alpha is only 2 degrees, but that's okay. Because now I can go back to my law of sines, and I know that 200, I'm turning it upside down, divided by the sine of alpha is equal to b over the sine of beta, which means that my side b is a sine of beta. Well, let's write that more intelligently. 200 times the sine of beta divided by sine alpha. So let's go ahead and label this alpha. There we go. Oh, okay, so let's do this. So 200 times the sine of beta divided by the sine of alpha. And I now know that that invisible distance, that b, is 2,330, we'll call it 1 feet. Now that's not what I want yet, is it? But that gives me what I need, because that means that h, the height of my mountain, is 2,331 times the sine of 22 degrees. So let's go ahead and label that guy b. And now I can find h is b times the sine of 22 degrees. $873 feet. Okay. So that's it for this section of this chapter. You're going to be using non-right triangles to solve problems, and you've now got 2 more tools to do that, the love signs and love cosines. Have fun.